Lesson 3.4, multiply two-digit factors using partial products. We can use place value and partial products to multiply two-digit factors. We can break apart the factors into tens and ones and multiply to find the partial products. Then add the partial products. We did this in video 3.3, the lesson right before this one, and if you missed it, it's linked in the description. To multiply using partial products is different than multiplying with regrouping, which we'll learn in the next lesson, video 3.5. And remember, we can turn our paper sideways to use the lines to keep our place values straight. We just learned to break apart a model to find partial products. We did that in video 3.3. And we can use what we learned to find and record a product. We draw a model, a nice rectangle. We're going to multiply 27 times 31. We break the 27 into a 20 plus a 7. We break the 31 into a 30 plus a 1. We draw our lines to make our 4 boxes for partial products inside. We have 20 times 30. We have 30 times 7. That's the 210. We have 1 times 20. That's 20. And we have 1 times 7, that's 7. We total up our partial products and we get 837. Now if that confused you, you need to go back into the description and watch video 3.3 because we learned how to do this in the last lesson. Before we multiply, we can estimate the product so we know what a reasonable answer might be. We need to multiply 27 times 31. The 7 tells the 2 to go up to a 3, then the 7 becomes a 0, so that becomes 30. And the 1 tells the 3 to stay the same, and then it becomes a 0, so we have another 30. We have 30 times 30. We can think of the basic facts of 3 times 3, which is equal to 9. We have 2 zeros in the factors, so there's going to be 2 zeros in the product. We have 900 for our estimate. We need to multiply 23 times 68. We do an estimate. The 3 tells the 2 to stay the same, and it becomes a 0, so we have a 20. The 8 tells the 6 to go up to a 7 and becomes a 0. We have 70. We multiply 20 times 70. We have a 2 times a 7. That's a 14. We have 2 zeros in the factors, so we have 2 zeros in the products. So we have 1,400. For our model, we break the 23 apart into a 20 plus a 3. We break the 68 up into a 60 plus an 8. Now we know we have 20 times 60, which is 1,200. We have a 20 times 8, which is a 1,600. We have a 3 times 60, which is a 180, and a 3 times 8, which is a 24. And we can multiply this with the digits stacked by place value. We start in the tens place to multiply using partial products. We have 20 times 60, a 2 times a 6 is a 12. We have 2 zeros in the factor, so there's 2 zeros in the product. That's 1,200. That's the first place values we multiply, is the tens to the tens. Now we're going to multiply this 10 to the ones up here. We have 20 times 8 ones. Because remember, that's a tens place, so that's really 20 for 23, isn't it? So we have 20 times 8. That's 160. Now we're going to multiply going this way. The 3 ones times the 6 tens, that's 180. Now we multiply the ones. 3 times 8 is 24. And see how each time I got a partial product, I wrote it underneath the last one. We draw a line, make a plus sign, and we add all of our partial products. We have a 4, and we have an 8 and a 2. That's friendly numbers, compatible numbers, aren't they? That makes a 10. Plus 6 is 16. We regroup the 1 and put the 6 down. We have 2, 3, 4, 5. We put our 5 down in the hundreds place. We drop down our 1. And we have 1,564. And it's reasonable because it's close to 1,400. Now, if you look at how we multiplied the tens, then we did these tens to the ones, then these ones to the tens, and then the ones to the ones. If you took these 4 steps and you kind of squished them together, they would look like a W. The order we multiply using partial products looks like a W. Do you see it? Down, up, down, up. So when you're multiplying for partial products, just remember the W. We need to multiply 39 times 24. For our estimate, we can use compatible numbers. 39, the 9 tells the 3 to go up to a 4 and turns into a 0, so we've got a 40. And we can say 25 for 24 to make compatible numbers. We know 4 times 25 is 100, and we have a 0 in the factors, so that's going to be a 100 with another 0. That's 1,000. We can break apart 39 as a 30 plus 9 and the 24 as a 20 plus 4. We draw our lines and make our 4 boxes for our 4 partial products. We know we're going to do 30 times 20, which is 600, and that's what we're doing here. We're doing 20 times 3 tens, that's 600. We can do 20 times 9 and get 180. That's going this way for our W, that's the second one, see that? Then we're going to go this way and do the 4 times 3 tens. That's 120. Then we have 4 times 9, which is 36. We can add them up. We have a 6 in the ones place. 8 plus 2 is friendly. That makes it 10. Then we have 3 more. That's 13. We regroup the 1 and put the 3 down. And we have 6, 7, 8, 9. We have 936. And it's reasonable because it's close to 1,000. So it's a reasonable answer. If you're confused about the compatible numbers, check the description for a link to video 3.2 where we learned about different ways to estimate. There are many ways to represent a product or a number. We just did 39 times 24. We found out that the product was 936. So our factors were 39 and 24. Our partial products were the amounts that we got. The products that we got when we multiplied each separate little part, we have our full product of 936. 936 can be represented as a 900 plus a 30 plus a 6. So that would be 900s plus 3 tens plus 6 ones. We can also group the 9 and the 3 together and say that's 93 tens and 6 ones. We can also break the 24 into a 2 times 12 and say we're doing 39 times 2 times 12. We can also do 468 times 2. That would be a way to represent 936. And we can even say 936 is 950 minus 14. Many ways to represent a product or a number. A candy store has 26 jars of candy. If each jar contains 32 pieces of candy, how many pieces of candy are there? We need to multiply 26 times 32. We can estimate the 6 tells the 2 to go up to a 3, and it becomes a 0, so we have a 30. And the 2 tells the 3 to stay the same and becomes a 0, so we have another 30. And 30 times 30 is 900. We think of 3 times 3 as 9, and we have 2 zeros in the factor, so we have 2 zeros in the product. We have 900 for our estimate. When we stack them and multiply them using partial products, we start with the tens. We have 20 times 30. Remember, we're starting and thinking of the W, so we have 20 times 30, that's 600. Then we do 20 times 2, that's 40. Then we do 6 times 30, which is 180. Then we do 6 times 2, which is 12. We add all the partial products. We have a 2, we have an 8, and a 4 is a 12, plus 1 more is 13. We regroup the 1 and put the 3 down. We have 6, 7, 8. We have 832 pieces of candy. And that's reasonable because our estimate was 900. Now we have to be very careful. When we write our partial products, look, these partial products are in the wrong place value. The 40 was supposed to be here with the 0 in the ones place and the 4 in the tens place, and it was accidentally written with the 4 in the hundreds place. So was the 12. See how the 1 is in the hundreds place and the 2 is in the tens place instead of the ones place? See that? When this is added up, we get 1,300, and we know that something must be wrong because our estimate said it should be around 900, and we have a much greater number. We have 1,300. We know we did something wrong, and we know to go back and look over our math to see where we made an error. We need to multiply 58 times 94. We estimate. The 8 tells the 5 to go up to a 6 and becomes a 0, so we have a 60. The 4 tells the 9 to stay the same, and it becomes a 0, so we have a 90. We think of the basic facts of 6 times 9, which is equal to 54. We have 2 zeros in the factor, so we have 2 zeros in the product. We have 5,400. To multiply them stacked for partial products, we think of the W. We're going to multiply 90 times 50. That's 4,500. We have a 9 times a 5, which is the 45, and 2 zeros in the factors, don't we? We have 4,500. Now we're going to go this way and do 90 times 8. That's 9 times 8 with a 0. So it's 2 with a 0. We have 720. Now we're going to do the third part right here. We're going to do 4 times 50. That's like a 4 times 5 is 20 with another 0 because there's a 0 in the factor. We have 200. Then we do 4 times 8, which is 32, and we add them all up. We have a 2 in the ones place, a 5 in the tens place. We have 7, 8, 9, and 5 more is 14. We regroup the 1, put the 4 down. 4 and 1 is 5. We have 5,452. And look, our estimate was 5,400. Just make sure that the partial products are in the correct place values. Otherwise, when we go to add the partial products, we're going to have an addition error. Now we're going to do some abstract reasoning. We need to find the unknown digits from the equations and complete the problem. So thinking of the W, we know we're supposed to multiply the tens place first. This digit times this digit is going to give us 7,200. And if you have problems thinking about that, let's go to the next one. This partial product says 90. 1 times some amount of tens is equal to 90. Well, 1 times 90 is equal to 90, isn't it? And if we wanted to write 90, because that's a tens place, we just put a 9 there. And that makes sense. We have 94, so that's 90. 1 times 90 is 90. Well, if that's a 9, what times 9? What could be the missing digit that would make this 72? Hopefully you have your multiplication facts memorized before you started 4th grade, up to the tens. So you should know that 9 times 8 is 72. So 90 times 80 would be 7,200. Now let's see if the rest of it makes sense. So that would be 90 times 80, that would be 72 with 2 zeros, yep. Then we have 1 times 90, that's 90. Then we have 4 times 80, that's like a 4 times 8, which is 32 with another 0, yep, that works. We have 4 times 1 is 4. Now all we need to do is add our partial products. We have a 4, we have 9, 10, 11. We regroup the 1 and put the 1 down. We have 2, 3 plus 3 is a 6. Then we bring down the 7. We have 7,614. Now look at this one. Look at these 2 digits are missing. We know, thinking of the W, that we're supposed to multiply these first, and whatever they are, they're going to give us 1,000. So 50 times some multiple of 10 is equal to 1,000. If that's too hard to think about, let's go to the next one. We know 5 here represents a 50, so we have 50 times 7, that's 350. It's like 35 with a 0, 350. So that makes sense. Now we know we're supposed to multiply these two blank ones, whatever they are, they're going to equal a 40. Then we have to multiply the blank one to the 7, and it's going to equal 14. Well, what times 7 equals 14? If you said 2, you're right. So we know that digit is a 2. So 2 times some amount of tens is equal to 40. Well, 2 times 2 tens. 2 times 20 is 40, isn't it? So we know that that's a 2. So when you're doing problems like this and you can't figure out what it is at first from the first partial products, go to the next partial product or the next one, thinking of the W so that you can figure out what they are. This was easy because we thought, well, something times 7 is 14. That must be a 2. And that helped us do the one here because we used the 40 as a partial product. Now we just need to add them. This becomes a 4. For the ones place, we have 5 plus 4 is 9, plus 1 more is 10. We're going to put the 0 down and regroup the 1. Now we have 1 plus 3, which is 4. We drop the 1 down. We have 1,404. Now look at this one. We've got a 10 missing, a multiple of 10, and we've got some 1s missing. And thinking of the W, we know we've got to multiply these first, and 20 times some number is 600. And if that's too hard to think about, we can go to the next one. This digit times this digit should be 120. Well, we don't know what they are, so that's not going to help. We can check this one. We have 8 times 2 tens. That's 160. Yes, that works. Then we have 8 times some number is 32. When the 1s are missing, we can start at the last partial product, and that will help us. So 8 times some number is equal to 32. We know 8 times 4 is equal to 32. That must be a 4. And if that's a 4, maybe we can figure out this first one here, or the second one. It says 4 times some multiple of 10 is equal to 120. Well, thinking of basic facts, 4 times what is 12? Well, 4 times 3 is 12. And because it's a 10, it's going to have an extra 0 in the factor, isn't it? So that should be a 3 for 3 tens. Now let's see if it fits for this first part. 30 times 20 is 600. That makes sense because 3 times 2 is 6, and 30 times 20 would have 2 zeros in the factor, so there'd be 2 zeros in the product. Now we just need to add them. We have a 2 in the 1's place. We have 6 plus 2 is 8, 9, 10, 11. We regroup the 1 and put the 1 down. We have 6, 7, 8, 9. We have 912. So remember, if you can't figure out the missing unknown digits, go to the next partial product, and if the 1s are missing, start down here with the partial products down below. Mr. Lee sold 18 boxes of tomatoes. How many pounds of tomatoes did he sell? So let's look at this table. It says pounds per box. We've got carrots, tomatoes, and onions, and it says weight per box, and it's got these blue dots. The key says that each full blue dot is equal to 10 pounds. Well, if each one is equal to 10 pounds, and we have 1, 2, and a half, that's 10 pounds, and half of 10 is 5, that's 25 pounds. So we know he sold 18 boxes of tomatoes that were 25 pounds each. So 1 box of tomatoes is 25 pounds. We need to multiply 18 times 25. When we go to estimate, we can use compatible numbers. We can use 20 for the 18 and 25. 2 times 25 is 50. We have 1 0 in the factor, so it's going to be a 0 in the product. We have 500 for our compatible number estimate. We need to multiply 18 times 25. We think of the W, so we start here. 20 times 10 is 200. Then we do 20 times 8, which is 160. Then we do 5 times 10, which is 50. Then 5 times 8, which is 40. We add them up. We have a 0 in the ones place. I see compatible numbers here. 6 and 4 is a 10, plus 5 more is 15. We regroup the 1, put the 5 down. We have 2, 3, 4 in the hundreds place. We have 450. And our estimate was 500. That's kind of close, so it's reasonable. So we know he sold 450 pounds of tomatoes. The product of 34 times 86 is greater than the product of 33 times 86. How much greater? And explain how we know without multiplying. So we think, well, 34 times 86 represents 34 groups of 86 objects. And 33 times 86 represents 33 groups of 86 objects. So there is one more group of 86 in 34 times 86. There's one more group of 86. That makes it 86 greater. So we know that this product is 86 greater than this product, and we didn't even need to multiply. Tala wants to use partial products to multiply 77 times 19. We need to write the numbers in the boxes to show 77 times 19. So if we're confused, we can start by drawing a model to help us. We can break the 77 into a 70 plus 7. We can break the 19 into a 10 plus a 9. Then we can draw our lines and make our 4 partial products. So we know we're going to multiply 70 times 10. We know we're going to multiply 70 times 9. We're going to multiply 7 times 10. And we're going to multiply 7 times 9. Now we've written all the numbers in the boxes to show how to use partial products to multiply 77 times 19. In our next lesson, 3.5, we're going to learn how to multiply with regrouping. I hope you're having a great day. Keep trying hard, and I'll see you next time. Bye.